In this video, we're going to go through graphing a quadratic equation again. We're going to start with just a few generic reminders that are going to be applicable to every single one of these graphs that we're doing. The x value of your vertex is the vertical line that represents the axis of symmetry. Your parabola is going to be the same to the left and right hand side of those because parabolas are symmetrical. The numbers in this table, and it says this table, this is the table from the question above, the x, y, ay table. Those are not ordered pairs that satisfy the equation. They are relative ordered pairs. They have been shifted based off of being the vertex as the origin instead of the actual origin. The a value of your equation will tell you about the general shape of your parabola. If it's positive, it opens up, and when we say parabola opens up, it looks like that. If it's negative, it opens down, which would look like that. If the absolute value of a is greater than 1, basically saying ignore the negative sign. If that number is bigger than 1, you are going to get a more narrow function. If it's less than 1, you're going to get a more wide function when compared to the parent function. Okay, narrow just means it's going to be taller, faster. Wide means it's going to stay pretty short, but stretch out horizontally. After you've graphed your parabolas, you can always tell if it's correct by finding ordered pairs that are on your graph, the actual ordered pairs, not just what you had written in your table, and plug them back into your equation. Remember, you can always make a table of values by plugging a number in for x, see what happens for y. The ordered pair or pairs where the parabola crosses the x-axis is the real solution. Okay, it could happen 0 times, 1 time, or twice. If it happens once, you have what's called a double root, and you need to specify that it is a double root. Okay, if it happens twice, those are just the two ordered pairs. If it doesn't happen at all, you have two imaginary solutions, complex solutions. They are in a conjugate pair. When you are writing roots, zeros, and solutions, you should write those as x equals some number, but if it asks for an x-intercept, you should be writing that as an ordered pair. All right, so now in number 13, we have vertex form being given to us, which makes life easy for finding the vertex. The vertex is the opposite sign of whatever that number is inside the parentheses being squared, and then the y value is what's being added on at the end when it's in vertex form. If you see something outside of vertex form, meaning you have other x squareds you have to add to it or something, this doesn't work. This is only for when we are in vertex form. So now I'm going to go over to 2, 3. There's my vertex. I'm going to pick x values of -1 and 1, -2 and 2. I picked them because since y is x squared as a parent function, -1 squared is 1, 1 squared is 1, -2 squared is 4, 2 squared is 4. I get a nice pattern. Now my a value here is 1/2. So this is 1/2 of x squared. This is 1/2 of everything we just found. Okay? This is a situation where it doesn't work out as nicely as I would have liked it to. Okay? But let's look at what's happening. This says if I go 1 to the right or 1 to the left, I go up 1/2. I don't really like to try to graph up 1/2, but if I go right 2, I'm going to go up 2. Left 2, up 2 from my new origin, which is the vertex. If I wanted to try to be more accurate, I would just find new x values. Knowing that I'm going to have to multiply something by 1/2, I'm just going to skip past -3 and 3 and go to -4 and 4. The reason I skip past -3 and 3 is I'm going to end up with the same situation I did with the odd numbers -1 and 1. I'm going to end up with a fraction. Now, -4 squared is 16. When I take that times 1/2, that's going to be 8. So if I went over 1, 2, 3, 4, I'd have to go up 8. 1, 2, 3, 4, 5, 6, 7, 8 is just off the graph. That's kind of a bummer. So I'm not going to count those as my 5 dots. I'm going to find another ordered pair. Oops, I only went over 3. I'm not going to get to use this quick table as easily. So what I'm just going to do is pick an x value somewhere in the middle here. I know that if I plug in 1 to the right, I'm going to get a fraction. If I go plug in 3 to the right, I'm going to get a fraction. I'm going to get a fraction. I don't really get much of a choice in the matter here. So I'm going to kind of eyeball a little bit. If I went over 1, I went up a half. If I went over 3, I would have had to go up, well, I didn't make that in the table, but I would have to go up 4.5. Because 3 squared is 9. Cut that in half, you get 4.5. Connect my dots. I've got more than 5 now. Most of them aren't pretty, but if I've got a lot of dots that are pretty close, that makes me more accurate. My domain here, x exists in the real numbers. I can have all x values, but I don't have all of the y values. My range is y is greater than or equal to 3. I don't have any real solutions here. I'm going to have complex solutions. I'm not asking for that at this point, but that's what's happening in this graph because we do not cross the x-axis. Have a great day, everybody.